Calc 3, you're kind of expected to be experts with arc length. So it's kind of like, well, how can you be if you only got like a few minutes of instruction? So that's the idea. So hopefully on Wednesday I'll be able to really drive home this concept. But right now I'll just give you the gist of it. Right? What we're saying is that if we have you zoom 300%, some particular interval along a curve, that little interval has a little tiny smidge of arc associated with it. All right, that arc corresponds to some circle. That circle has a radius. If you have the radius of a circle, then there's a lot of things that you can do. You could find, S equals r theta. You could find arc lengths. You need to know something about the angle, or you could use a little arc length to find the angle, but you would have that information, because what this ends up being is some ds. You have an r and some arbitrary change in, sorry, not arbitrary, I'm using that word a lot, minuscule or infinitesimal change in theta. Okay? And so you'd have many more, because I just took a tiny little smidge, you have many more tiny little smidges. Those tiny little smidges all correspond to circles, all with the same characteristics. So some bigger, some smaller, but every one of them has the same set of characteristics. And if I were able to find all possible circles from A to B, all possible smidges, then I would have the arc length, right? So I just need all of those DS's, every single one of those DS's. And if I can do that, I just add them up, right? Fortunately, the integration process, the summations that lead up to integration allow us to do that, right? So what's happening here, and this is Calc 3, but this whole shebang here is your DS. The minuscule distance of arc length, all right? So if we could just find whatever that expression is, and then next class I'll show you where it's really cool origin, little proof. But if you come up with this expression which represents that infinitesimal change in arc length, then integrated on the interval, you have the entire arc length. It's really awesome. All right. So again, just to make it abundantly clear, hopefully, arc length, that's always been S. So ds is really talking about the really teensy tiny little change in arc length. All right. So that's a little bit of the theory. Now, in terms of practical application, it's okay. Now that you understand all of that, just follow this formula and get an answer. Type in your calculator, hit enter. All right. Because if you look at it, it's pretty straightforward. It's saying find the derivative of f of x. That's what the inner part there, that f prime is talking about. That part you're going to want to do because you can tell the calculator to find the antiderivative of a derivative, but it doesn't always listen. All right? So I have f of x is equal to the natural log of cosine of x. Normally I'd put whatever's in the natural log in absolute values, but it's on the interval of 0 to pi over 4. Cosine's positive in that interval anyway, so it's immaterial. So I need the derivative. We talked about this way back when, but the derivative of a natural log function is 1 over whatever's contained within a natural log multiplied by the derivative of that contained expression. So I'm going to write it just so you have it. The derivative of that. So 1 over cosine x. What's the derivative of cosine? Negative sine. So sine x over cosine x is tangent, so this is negative tangent. All right, this is a problem that's actually pretty user-friendly if you use the by hand approach, but again, we don't need to, so don't. All right, so S is going to be the integral on the interval of a to b, pi over 4, 0 to pi over 4, the square root of 1 plus the derivative of my function, so negative tan squared, negative tan x, sorry, quantity squared, the root of that dx. Right, you can clean it up if you want. Just make sure, like little things that, I mean, the question would have to be phrased slightly differently, but tangent can be undefined at certain locations, so just make sure it doesn't happen on this interval, and it doesn't. The first time tangent is undefined is at pi over 2, so we're in good shape here. Math 9, 0 to pi over 4. The square root of 1 plus, I'm just going to write it as tangent squared because that negative is going to square away anyhow. Tan x, close the parentheses and square it. For some reason, that's how the calculator understands powers for trig functions. Dx. Hit enter. Put down your answer confidently, and then sheepishly check your mode and make sure it's the right mode. Because you might have confidently put down the wrong answer. We're good. Radian mode. All right, so that length, that little distance on the interval of 0 to pi over 4 is just that. It's little. I mean, you can look at the picture. The original function was the natural log of the cosine of x. I'll just do a zoom. I'll do zoom 6. Right, so this is kind of what the graph would look like. Now, if I'm going from 0, second trace, I'll do value. Type in the 0. That's putting me right here. If I put in a pi over 4, second trace value, pi over 4, it's only putting me a smidge to the right. So 0 was at the origin, pi over 4 is here. It's a very tiny little piece of graph. So I'm not expecting a large number. But I also didn't really think to look at my calculator until after I saw that tiny little number, and I just wanted to make sure it made sense. All right? But really, that's all there is to it, because it's, in the second one, find the length of the arc of the graph of this. I write it first as 1 over 6 x cubed plus, and I'll write this as 1/2 x to the negative first. Because I need to take the derivative of it, I want it to be in a nice power rule format. So that'd be 1/2 x squared minus 1/2 x to the negative second. All right, that's only for the purpose of getting it into the calculator. This is happening over the interval of 1/2 to 2. All right, it's 1 plus f of x. Well, this certainly is a function that's defined in terms of x. So a good question would be, well, how do I know when to use the other formula? Well, if they give you a function defined in terms of y. Right? So there's no like, where's my rectangle going to be? It's how is the function given to you? And I mean, I guess if you weren't allowed to use the calculator, you might say, well, is it more convenient to work in this form or the other form? But I don't think that's relevant here. Then we go to the calculator. enter, long last. This one is frackable, math, enter, enter. Take all that. Not too bad at all. Movie reference. Independence Day. It's the president. That's it. Not too bad at all.